Hi guys, welcome to my NX11 training. I've already fired up NX, but what we're going to try and do today is get you into using NX for the first time. We're going to do some simple parts, model them and bring them together as an assembly, and then do a drawing of them. So that pretty much covers most of what you need for NX. So we're going to model a V-block, clamp and screw, and it's going to look something like this. So this is what we're going to try and model. Just a simple V-block, the clamp and the screw. I think we're going to go for 38 by 38 by 50 millimeters. So something quite simple. Right, so got an X. I'm going to start a new part. So I'm going to go new. It comes up with this. And basically we just want to create a model. It's already on millimeters, it's set to model. This system does a lot of things, a lot of different things. We're just going to use the basics of this to start with. We need to know where we're going to store all the files that we create, and at the minute it's set to the C drive. I don't want to create it on the C drive, so I'm going to pick a different location, desktop. I'm going to create a new file in here called NX training, and this is the file we're going to store all the new files to. Okay, so anything we create now in this session of NX will get stored to the desktop. It's on model, it's on millimeters, that's okay. Right, so when you first create a new model, it automatically puts a data and coordinate system in, as you can see on the screen, with the X, Y, Z coordinate. Before we start talking about NX and how to model, you first need to know roughly what's going on in the interface. This part navigator tells you how you make up your models with your model tree. So you start off usually with a sketch, and then you add to it, subtract to it, and you build up your model further down this tree. This one is to do with assembly constraints, and it shows you all the constraints you put together for constraining one model to another model to make an assembly. And then the top one, you've got an assembly navigator, and this tells you the different models that you've got that make up an assembly. We've only got this model 1 at the minute, so it doesn't really matter. You need to be a little bit careful on what you call the model files. If you're working at home, it doesn't matter so much, because potentially you've only got one model that's called model 1, but if you're working in a work scenario, potentially there can be lots of model 1s. And when you load the assembly, you need to know that you're loaded the right model. So where you save the files is important, and what you call the file names is quite important as well. NX has got quite a good basic out of the box setup. There's some things in here that I really don't like. Some things work quite well, some things not quite so well. There's a very, very good command finder here as well. So if you know what command you've got from SolidWorks or Pro E or a different CAD system, you might be able to find what you're looking for here and use it in a very similar way. These CAD systems are very, very similar nowadays. CATIA, Pro Engineer, Inventor, SolidWorks, etc. They're all very similar, they work a similar way. NX is quite difficult if you've not used NX before or not done any training in it. It's a little bit more difficult than SolidWorks to pick up from scratch, as it were. Right, so Got some commands across the top, and we've got some tabs across the top. So we've got a home tab, curve, view, assemblies, etc. So there's some different commands in here. Also in the menu, there's various commands in the menu as well that we can use. One of the commands I normally start with is called Sketching Task Environment. It's a little bit different to this sketch in its own right. I think this tool is slightly better than this sort of direct sketch tool. This by default I think is in the curve command. I've actually added it to my home tab, and to add it to your home tab you can search in the command finder, for example sketch, and it brings up everything to do with sketch and it tells you where the commands are. You have to be a little bit careful because some of them are like shortcuts, so this is shown as a shortcut, so this isn't the actual button we want. So if we go down, Sketching Task Environment, so I'm highlighting it here and it's actually highlighting where it is in my toolbar, and it's under the home tab. If I wanted to add this to my home tab, I can just click on this little arrow and then add it to my current tab, home tab, whichever I want. If I then want to move the button around, I can right click in the background, I can go customize, and now it comes up with all these commands. I can add any of these commands into my toolbar, but also now it lets you move the toolbars around, so you can actually grab them and drop and drag them exactly where you want them. So you can move this tab, for example, over here or over here, wherever it suits best. Right, so the first thing we're going to do is we're going to do a sketch. So click on Sketching Task Environment, comes up with this box, create sketch. Now I can hit OK, or I can press the middle mouse button in and it does the same thing. The middle mouse button is sort of a shortcut, it makes it go faster. Right, so now I'm going to do a sketch for this V block. Many different ways of doing this. It's better if you draw it roughly the right scale. Now the idea is on this type of system, you don't draw something exact, you draw it roughly and then put dimensions in after the fact, and also geometric constraints. So let's start by putting a rectangle in. Now if you look on this rectangle, it's put different constraints on the rectangle. So it's put a constraint here and a constraint here, here, here and here. Now by default I prefer not to do this way of modelling. I prefer to use what I would call a primary constraint, which is a horizontal constraint or a vertical constraint first. Then I start using these perpendicular constraints and various other constraints after the fact. There is a way of changing this in the system to put in the constraints that we want, but for now I'm just going to delete these 90-degree constraints by highlighting them and deleting them. If you do it fast enough you can delete it straight away. If you highlight there and stay there, 3 little dots appear and then it gives you the option, if you left click, on what's at that location, and it's this constraint we want to delete, so we can delete that one. If you look now, if I drag this, it's now going out of square. Now you have to be careful because if I drop this point here, it's going to put a constraint on. You can see to the left of the cursor, there's a constraint that's going to be put on there. That's not what I want. So if you look, it's no longer 90 degrees. So I want to put a constraint on these lines similar to this one. So if we go constraints, now I want horizontal on the bottom, so just left click, and I want vertical on the 2 sides. So now I've got matching constraints, the same type of constraint on this box. Now we want to make sure we model this as 38 by 38 by 50 deep. It's always best to fully constrain the sketch. At the minute this sketch needs 4 constraints. When you open NX up out of the box, there tends to be a button on called Auto Dimension, and this, what it does, it creates dimensions as you sketch. Now I don't like this particular feature of NX, so I turn it off by default. I'll just show you the difference. I'll just do another sketch. Let's do it on this axis, or this plane. What else we got in here? There we go. So this feature, this continuous auto dimension is now on. And if I draw a feature or anything on here, you can see now it's putting in automatic dimensions. And I don't like the way it does this, because the system doesn't know the best way of dimensioning or constraining something. You need to dimension it and constrain it depending on what the actual intent of the part is. We can obviously change these dimensions here by typing in what we want, and the other dimensions will change around it. But it's not my preferred way of doing things. I prefer not to have this feature on at all. Right, so if you look here, we've got the coordinate system. I've got this sketch, and if you look, there's like a little blue outline on this particular sketch here, and basically what that's showing is this sketch is still active. We've not finished this sketch, so we need to finish the sketch. And this is the sketch I don't want, so I can highlight it, right click on it, and now we can delete it. So I want to go back into this first sketch that I've started here. Number of ways of doing that. I can double click it, but then it will go into the direct sketch. I want to go back into the sketch in task environment. So if I highlight it, right click, and edit with rollback. Now into the sketch. Now what I recommend here is just putting this in space where it should be and at the right size, and then put in the cutouts and things after the fact into the sketch. That way we know we're sketching roughly at the right scale. So we can go rapid dimension, make sure it's on inferred. Inferred basically means it's going to guess. It's going to guess what we want depending on what we click on. And if you look here at the end of the arrows, it's trying to tell you that this line can move in this direction, and this point can also move in this direction. So it's telling us there. And these are the constraints that we've got. So I'm going to put a dimension on this line, and I'm going to make it 38. And if you look, the system gives it a parameter. So this 38 is P6, and I can match the parameter in this direction by saying P7 equals P6. Therefore, if P6 changes, this size will change to match. I also want to make sure I'm modelling this in the right place in space, and I want to make sure it's in the middle of the coordinate system. So I'm going to, right, so here I need to select another dimension. A way of starting this rapid dimension again, because I've sort of come out the command, is I can highlight it here saying reset, then I can click on it again from here to here. I can say P6 divided by 2. From here to here, P7 divided by 2. So if you look at the bottom, sketch is fully constrained. So this is sort of the starting point for doing this V block. I prefer to work this way rather than trying to sketch the whole lot. I think it's easier. Right, so if we go on profile, and on profile it's joining up the lines by default. We have to be careful that the right button's pressed in here, and it's the one called create infer constraints. If you look on the left hand side, it's pushed in. This one's not, but that one's pushed in, which means it will join up the lines. It will do the constraints, the default constraints, as we're sketching. Right, so these are my snap points. So when I draw the V into here, I need to make sure it's touching this line, and if you look there, it is touching the line because this one called point on curve is on. So if I click on here, I come down, I make sure the vertical constraint's on, make sure the horizontal constraint's on. Now if I stop here, it's going to put a constraint to make sure this point is level with this point. I don't like this particular constraint, so I'm going to over exaggerate it, and I'm going to draw onto there. So that's my first starting point for the V. I'm going to chop this piece out the middle, and by default the system, because this was a single line, it'll make sure that this side of the line and this side of the line are always in line by adding a collinear constraint after the fact, after I've cut this piece out the middle. So let's trim it out, trim, quick trim, it's one click, it's gone, and there's the extra constraint it's put on for us. Right, so now I want to make sure that and that equal length. This is the one I prefer, the constraint I prefer. So let's go on equal length. At the minute this button is not pressed in, so I have to hit this, left click on this, middle click, left click, and that lines it up. You can go in here and do it manually, but it takes a lot longer. Right, so now I want to make sure this is 90 degrees, so let's go perpendicular, left click, middle click, left click, so it's 90 degrees. So I tend to go around the sketch and put a few dimensions on, a few constraints on, and build it up slowly. So rapid dimension. Now I'm going to put an angle in. So if I click on this line, I can put a 45-degree angle in. Right. So if I want to know how the sketch can move, if I go on one of these, either rapid dimension or constraints, it will tell me how the sketch can move here, by these little arrows. Also, you can actually drag the sketch to see how it moves. Right, so I want to give a size to this undercut. Let's make it 5mm. And from this point to this point, I'm going to say P11 divided by 2. Always want to keep it in the middle, and I'm going to give it a length of this line of 4, maybe 3. And basically what I'm after here is a V-block's usually used to hold a round bar for drilling a round bar or similar, and I want to make sure the V, the very bottom of the V, is slightly higher than the undercut, so I've got a little bit of clearance here. And 3mm looks about right. I'm going to try and change the sizes and see how that affects where that point is. So now I need to drive the size of the V, and I can do that just with one dimension in here. So if I go 3mm, it makes the V big. If I go 8mm, it makes the V smaller. But if you look, the design intent is maintained. The V is always in the middle of the block. So I think this side will have a big V, and on the other side will have a small V. And if you look, the sketch is fully constrained. So now I'm going to add the small V to the side. Profile, click, click. You see then it added a constraint there. It made the end of that line in the middle of that line, which is not what I want. So I'm going to hit the escape key. I'm just going to delete that constraint there. Horizontal alignment constraint, delete. And now I'm just going to draw a single line in, connecting the end of the line to there somewhere. Right, now I'm going to line up this cutout with this cutout and make sure these are the same length. So equal length, left click, middle click, left click, and I'm going to make it collinear. This line, left click, middle click, left click to that one, left click, middle click, left click. So that's in a line. I'm going to go equal length. I'm going to make that line equal length to that line. And I'm going to go perpendicular from there to there. P10. Let's chop out the piece in the middle, quick trim. What have we got now? So if you look, the green lines mean it's constrained, the brown lines mean it can still move. So what's missing now is the length of this line, and that will drive the size of the V. about something like that. So it's very easy for me to change the size of these V's. It's very easy for me to change the overall size, and everything will stay in the middle. I just need a couple of cutouts now for the clamp to go in. Let's go across, make sure the constraint's on, down, constraints on. Now here, NX will either join the line or it'll put a constraint on. It won't do both. It will join the line or it'll put the constraint on. So in this case, I'm just going to make sure it puts the constraint on, and then I'm going to trim it back. So I'm going to trim that and trim that. And on this side, I'm going to do it the opposite way. So let's go profile. So I'm going to click on this line, come across, down. I'm going to click on the line and then make it straight after. And then trim it away. Right, so let's drive this side using this side. So I'm going to put all the dimensions on the left side, which will drive the size of this, and I'll make sure this matches. So let's put the length of that on. Let's say, I don't know, 10. Let's make it 8. Let's go from that point to the centre. P17 divided by 2. And let's go for 4 mil. Right, so I'm going to make the same on the other side. So let's go collinear, left click, middle click, left click, left click, middle click, left click. And let's match the length of that line to that line. Right, if you look, when I trimmed it away, it's gotten rid of a dimension somewhere. So if we go back on either on constraints or dimensions, it's got one constraint that's disappeared, and it looks like it's the one that goes from the center to here that's gone. It's disappeared. So from there to there, and that should be P7 divided by 2. And if you look at the bottom, sketch is fully constrained. So that pretty much does what I want in the sketch itself. It's got the constraints that I want, and to move this around, I can change this dimension or this dimension, and that does what I want to the V's, or I can make the block bigger or smaller with this dimension. Right, so I'm happy with that. The sketch is fully constrained. I can finish the sketch, and now I can extrude it to give it the 3D shape. Extrude, pick the shape, and now just the depth. So we can move it around with this. I can type it in here, I can type it in here, I can flip it around. I think we're going to make it 50, I think we said. Right, so that's my V-block. So I want to save that. So I'm going to go File. There's different save buttons. We've got Save, Save Work Part Only, Save All, Save As. There's different options for different scenarios. In this case, we can hit Save. There's only one part on the screen, and this saves the work part and any modified components. If you're working on an assembly and someone else is working on the same assembly, you need to be very, very careful which save button you press. Generally speaking, most people work with inside Team Center or a PLM system, which stops one person overwriting the files of someone else. But if you're working offline outside of a PLM system, you need to be a bit more careful on which button you press. If you're working on an assembly and you're modifying only one component within the assembly, you really want to save just that work part. Save work part only. This one's a lot safer than pressing Save or Save All. So here it doesn't really matter. I'm going to hit Save, and then I'm just going to say OK. Right, so now I need to do item 2. Let's go New. We'll leave it on Model 2. You can see here it's saving it to the same location as before. Model millimeters. That's OK. Right, so let's do a sketch again. Sketch in task environment. Right, so let's put a circle in somewhere, another circle in somewhere. Right, so this can be the arc. There's different ways of drawing this, and actually NX with this particular profile tool, it actually lets you do arcs and things, but I prefer to put the circles in and make sure it's putting the right constraints on. But if you use this profile tool, you can actually click, and then you go in the direction you want the arc to go in, and then you hold the button down and you can actually draw the arc straight away. So if I want to go in this direction and move the arc in that direction, hold it down, click on, for example. So you can draw the arc straight away, but I prefer to draw them in circles generally. Right, so I want to make sure this is in the centre of my coordinate system. So I'm going to go on constraints. I'm going to go on point on curve, left click, middle click, left click. So now my two circles are on the centre line of this. I'm going to draw a line in, a line in. I'm going to make it tangent. Let's go tangency, left click, middle click, left click, left click, middle click, left click. And I'm going to trim it back. Right, so got another line coming in here somewhere, another one here somewhere. Let's go tangency, left click, middle click, left click, left click, middle click, left click. Let's just trim it back a bit. So I've sort of got the shape now, it's coming along. So I want to go, let's just move that. I'm just going to move this up a little bit. So let's go up that way a bit. And that one. Move that line down a bit. There we go. Profile. Start there. Come across. Come up. Come across. Come across. Up. Come across. And if you look, I'm just over exaggerating it a little bit so nothing lines up at the minute. I'll line it up after the fact when I want to line it up. Right, so constraints, collinear, line this one up with this one up with this one, and this line up with the coordinate system. Let's put some dimensions in. When you put dimensions in, it's usually better to put the smaller dimensions on first because then the sketch doesn't overlap itself. Just makes it a bit easier. Let's make that 8 for now. I can't remember what I needed to make it. Let's go from there to there, 60 or something. Let's go from there to there, make that, I don't know, 10. What else we got? Let's just drag that out a bit. There we go. And I think I made that 38. So this wants to be a little bit bigger than 38. I think the general drawing tolerance on most drawings plus minus 0.25, so I think I'm going to make it a millimetre bigger overall. So from there to there, so that wants to be 39, and let's put a size on there of 4 to start with. I'm going to match the length of that line, equal length that one with that one. There we go. Sketch is fully constrained. That's about right. I think that 10 is a little bit big. Let's try and make it a little bit smaller. Let's make it 8 for now. We can change this later. Right, so that's my starting point. Sketch is fully constrained. Finish sketch. Let's extrude it. Let's make it, I don't know, 16. Right, so now there's a screw that needs to come through here, so we need to put a boss on with a threaded hole coming through. Now, I'm not sure the height of this is going to be correct yet, so the height of this may go up or down. I want the boss to go up or down with it, so we need to model it relative. Right, so what I'm going to do now, I'm going to put a work plane on top, and drive the top surface with the work plane. So let's put datum plane. If I click on the, it's on inferred, so it's going to guess depending on what I click on. So I'm going to click on the bottom surface and the top arc. And if you look, it's sorted on what I wanted. Let's type in 0. That's actually what I want. So it's a work plane that's tangent to that arc. So if I move this sketch up or down, this work plane will go up or down with it. Right, so now I'm going to put an offset work plane in from that one. I think we'll make that 5mm to start with. And for now, to make sure I sketch on the right plane, I'm going to hide the bottom one. It will still drive the top one, which is what we want. Right, so now I'm going to do a sketch on this surface. Let's go sketch. Right, so let's draw a circle. Right, so I want the circle on the middle. So let's go point on curve, that one with that line. And now I don't want to put a diameter in because I might change the thickness of this later. So I want this circle to go with the thickness of this. So I think what I need is another work plane in. There's a work plane here, so I can use this one. So I can make it tangent, this circle, with this plane. However, it won't work on this side because there's no plane there and the surface is below where I am. So let's close that. So let's finish the sketch for now. So what I want to put in now is a plane on that surface. At 0. Now, if you look, the plane is actually below the sketch. If I highlight the sketch is relying on this plane, this extrude, and this extrude is relying on this coordinate system. However, this plane is after the sketch, so this sketch can't see what's after it. It can only see what's before it. So if I click on this plane is relying on this extrude because the extrude is now in red. So I can drop this plane before or just after the extrude. I can't drop it before, I can drop it after the extrude, but before the sketch. And then this sketch will see this plane. So let's edit this. Now we should be able to use this plane to constrain that circle. Tangency. There we go. Sketch is fully constrained and it's got no dimensions on it. Finish sketch. Extrude. Pick the circle. It's going the wrong way, so I'm going to double click the arrow. It's now going the right way. Now we need the surface to stop on that surface or that surface, and then we need to join the two solids together. So the end surface, if I go here until selected, then pick the surface, it's now going down to touch the surface. But if you look, the Boolean is none. It's set to none. It's not guessing what I actually want. What I want is it to unite. Okay, to that. So now that should be one solid, and I can check that by going up here on this selection filter, and if I select solid body and I select the bottom, the whole lot is highlighting. Yeah. Just be careful using this because if you're trying to double click the sketch or something, it won't let you because you've got the filter set. So always go back and turn it off after the fact. Right. If this one hadn't booleaned properly, you wouldn't be able to put the radius around it. So I'll show you what I mean. Let's go back to none. If you look now, if I select here solid body, I've now got two solids, not one. So let's go back to unite. Solid body. Now I've got one solid. Right, so it should let you put an edge blend around it or something. Around it. That's probably a bit big. Something small, like that. And let's just hide these planes for now, I think. Hide. Right, so there's the clamp. Just need to put the hole in it. Right, so we can use the hole tool. So we click on the hole tool. It's got general hole, we want a threaded hole. Let's go threaded hole. It's in metric already, so we can set that here, which is what we want. So this is it's a symbolic thread, it's not a cut thread. If you have lots of cut threads in thousands of bolts, it makes the system very unusable, very difficult to spin anything around. The symbolic thread uses a lot less resources and it's a lot easier to spin things around. But I think we'll put a symbolic thread in this one, and the screw we'll put a cut thread in to show you the difference. Right, so M12, let's leave on M12, it's probably okay for what we want. Now you have to be careful where we click on here. If we click on the surface, the system will do a sketch on the surface. Now we've already got what we need to do this hole straight away. We've got this circle, and I want to put the hole in the middle of that circle. So here on the snap points, we just need to make sure the right snap point's on. Mark center. Make sure you select the outside edge there, and then it will do what you want straight away. And it's already got through body, full thread, subtract, okay. Right, so that's pretty much what I wanted to do for now on that one. Let's just save it. Right, so let's do the last component, and then we'll put them together as an assembly. Let's go File, New, Model 3, that's okay. Right, this time we're going to do a revolve. We could do the screw as a series of circles, one put on top of another circle, but it's not a very good way of modelling, and it makes it very awkward. The model tree becomes quite large for no reason at all really, and it makes it more difficult for someone to change it later on. So you're better off doing it as a revolve. So let's do a sketch. So in this case we're going to just draw the profile roughly out. Let's put an undercut in it. Make sure it's not clicking onto anything I don't want. You can hold the Alt key actually. Let's come down at an angle, across, down, and across, something like that I think. Right. Let's make that 12. Again, it's better if you put the smaller dimensions on first. Let's make that 5, I think. 5. From there to there. Make that 3. From there to there. Make that 15. Let's go from there to there. That's 60. Right, let's put this on the center line here. So let's go collinear. So if I revolve this around this center line, I'll end up with a big hole here, and I don't want that, so I want that to be touching the center line. So let's make it collinear. Left click, middle click, left click, left click, middle click, left click. Right, let's just drag that up again. Right. Let's go for a diameter from here to here, from here to here. Let's make that 10 divided by 2. From there to there, let's make that 12 divided by 2. From there to there. Oh, let's move it the right way first. Let's just drag it the right way. There we go. Let's go from there to there. And let's make this, it was M12. So make this down to 10 divided by 2. Tapping drills 10.25. So the underside of the thread should just miss that diameter. So we can screw cut it into that thread. Let's go from there to there. Let's make that 20 divided by 2. That'll do. And let's put a couple of little radiuses in. So we haven't got any stress razors here. So we're using the fillet tool. Just click the two surfaces. Right, so I'm going to go equal radius, left click, middle click, left click. And I'm only going to make it something like 0.4 of a millimetre. Let's go radial. 0.4. No, not bad. Let's put some chamfers on here as well. Right, so here if I want to change the size of the chamfer, I just need to change this one dimension and everything else will change around it. So I want to make that 1 mil, 1.5, so it makes it life a lot easier later on, because when you're designing something it's never right first time, every time. You always need to tweak it a little bit here and a little bit there, and things like this make life easy. Right, the sketch is fully constrained. Wasn't really looking at the constraints or anything. It just happened by me putting the dimensions on. I think I'm going to put a little chamfer on there as well. Like that one. Maybe not 0.5. Right, so that's pretty much the screw I want. Let's finish the sketch. It's fully constrained. So instead of extrude, I'm going to revolve it. So if I click the little arrow, revolve. If I select the shape, middle click, select the axis. It looks like whatever I did last wasn't a full 360. So let's put a 0 in there. There we go. So now we've got the screw. Let's screw cut the thread on it this time. Right, so let's go thread. If you can't find thread, if you type it in here, then you can add it to your toolbar, or you can click on the feature direct. Right, so we've got symbolic and detailed. This time I'm going to do a detailed thread. I'm going to click on the diameter. This is a bit confusing on what to do next. What it's actually asking is, where are you starting the thread from? Where's your front face? So the arrow is actually going the right way. We're actually screw cutting it this way, and the front face probably wants to be here. If you try and select it here, it probably will miss the very first bit. It's better if it's this side of where you want to start the diameter. So if I click that face, the thread's okay. It's already picking up M12, which is what I want. And it's done the thread. If you look, it's not quite done the thread, it's not quite rolled the thread off the end properly. It doesn't quite finish there properly. So what I want to do is I'm going to extend the thread length a little bit. Let's double click it here. Feature dialog. Length 60, let's go for 63. So if you look, that's now finishing in this undercut. And it's now screw cut it right off the end, which is what I want. Right, so now I want to put a hole in here for like a Tommy bar. And again, the information that we want is already here. We can use the information here already. So let's use the hole tool. So we don't want a threaded hole, we just want a through hole. General hole, normal to face, diameter, I don't know, let's try 4. And we want to put it in the middle of this diameter, in the middle of this surface. So let's go, make sure we've got the right snap on. So we want midpoint, and we want to select this line. Through body, simple, okay. And let's just put a little nice radius around it or something. Let's go for an edge blend across there and across the other end. Let's go 0.5. That's pretty much what I want. Let's save that. Right, so now we can put this together as an assembly. So start an assembly. So let's go new, assembly, assembly 1 millimeters. Right, what I tend to do first, I put the coordinate system in. Before I put any parts in, I like to put a coordinate system in. By default, the system doesn't put a coordinate system in, so let's just cancel this to start with. And where we've got data and plane, we've got here the coordinate system. It's already 0, 0, 0. Let's say OK to that. And if you look, it's now put the coordinate system in. That's usually what I use as a starting point. I've actually added the tools, the adding tools for the components into my toolbar under the home page. However, they're under assemblies as well. So if we go add, and if you look, NX knows what's open in the background. It knows model 1, 2 and 3 are still open. So I've not got to select it from here, from a particular file on my system. I can select it from sort of the background, one of the background components. Whenever you're doing anything in NX, if you're changing a drawing, you're better off opening the components up, opening the drawing up, and then modifying the components with the drawing open in the background. That way NX tends to update a lot better, and a lot less dimensions tend to fall off and need reassociating. So let's put my primary first modelling, which was model 1. I want to use that as sort of the master model. Let's, it's going to put it in its absolute origin. You can actually put mating constraints on or assembly constraints on straight away, but I'm just going to dump it in the assembly to start with. There we go. Right, so if I look here under Assembly Navigator, I've got Model 1. So I've got an assembly, it's got the 3 cubes, and underneath the assembly, I've got my Model 1. Right, so we're under Assembly tab here. I can move the component by clicking Move Component, click on the block, middle mouse button, and I can click now on where I want to move the block. So I can manually move it around, and I can manually rotate it around using these dots or arrows. In this case, it doesn't really matter in which orientation the block's in. However, if it did matter which way around the orientation was and you needed to know which orientation this was modelled at, what we would do is we'd click on the model here. At the minute, the system by default creates this reference set called model. So what it's doing is putting the 3D solid on this reference set called model, and it's not putting the coordinate system that this component was made up from, or the sketches or anything else. It's just putting the 3D solid on the model reference set. However, we can change that to see how this was created relative to this coordinate system in this assembly. So if I right click on here, replace reference set entire part, I now know which way around this component was modelled relative to this component. So if it was important, we can do that. However, in this case, it doesn't really matter. So I'm going to right click, replace it with the model reference set again. If you look here, there's a position tab. If you look, it says unconstrained. As we constrain the model sketch, we need to now constrain the model in this assembly. So we need to fully constrain it in this assembly. It's better to fully constrain it, especially if you're going to do a drawing of it. You don't want things to move after the fact. Right, so let's try and put this model in the middle of the coordinate system this way, and probably in the middle this way. We'll probably touch the bottom face onto that surface there. So let's go Assembly Constraints. Comes up with this box, and we want center, and you always go from the component to the component, or from the component that wants to move to the solid component that doesn't want to move. So let's go, we want to go, say, 2 surfaces to 1 plane. So it's 2 to 1. And it doesn't matter which face you pick first or second, as long as you're going from this item to this item. So let's pick that face, and that face, to that plane, apply. And if you look, it's put this constraint in here. And if we highlight here, it's partially constrained now. And if we look here, it's put a constraint in, and it's the same one that's here. Right, so let's constrain it in this direction. So we're on 2 to 1 still. Left click, and left click, apply. And let's touch the bottom surface onto this plane. So let's go onto this one, touch a line, and it's on prefer touch. You can touch it, align it, or infer the axis. However, if we put the other 2 constraints on first, it will always go the right way. So you can leave it on prefer touch and it should do the right thing straight away. So let's click on the bottom surface and let's click on this surface, apply. And if we look here, fully constrained. Everything's up to date and it's fully constrained. Right, so let's just hide these constraints that are in the view. So if I highlight this one, if I press the shift key, highlight the bottom one, right click and hide. Right, so now I can add my second component. So let's go add, model 2, absolute, okay. I always find it's better to move it to roughly the right orientation that you want before you start putting constraints on it, because then the system will always go the right way. So let's move it roughly. So left click, middle click, let's drag it up here somewhere, let's rotate it round a bit and rotate it up a bit. So I want it roughly in that orientation. I think I'll center it again. So let's go constraints. So if you looked, I put the first component in, I constrain it to coordinate system. The second component, I'm going to constrain it to the first component generally. So let's go center. So here I want 2 surfaces to 2 surfaces. So 2 to 2, that one and that one. And it doesn't matter if I pick this one first or this one first, it will do the right thing. Hit the apply. Right, so let's put one constraint in. It's centered it this way. Let's center it this way. So let's go center again, 2 to 2. That one and that one. That one and that one. Apply. Right, so if you look here, it's now partially constrained. If I try and move the component, it won't let me move it in that direction or that direction, but it will let me move it where it's free to move still. Right, so let's touch this surface onto this surface, because when it's used and the screws screw down to a round item, this surface will get pulled back to that surface. So touch a line, I'm going from this item to this item, apply. Again, I can hide the constraints just by, if you look here, the hidden ones are just greyed out a little bit, and the ones that are not hidden are slightly darker. Let's put the screw in. So let's go add. This is model 3. Let's move it roughly into the right orientation. That'll do. Let's put it in the hole. So when I touch a line, I can actually infer the axis. So if I highlight this diameter and then come across, it's now doing the center line to the center line of this. Right. And now I think I'm going to put a distance constraint in. So let's go distance from the bottom of there to the top of the block. Let's go 5 maybe. If you look, the screw's a little bit short, so we can adjust the screw length, or we can change the outside length of this. Let's make that 0. Right. And if you look, we're now partially constrained. We need to constrain it. We need to stop it from rotating round. So let's go. Let's put an angle constraint. Let's highlight the centre. Let's do it to this surface. Let's put in there 0. Okay. Let's just hide them 3 items. Right, so I've now got an assembly, 3 items in here, all fully constrained. I'm just going to save it. Save, save. Okay, so it saved everything now. Right, so what I want to do now is make this a bit smaller. So I'm not going to go into the individual item. So the individual item would be under window. I can go back into the individual item. However, I can change it relative to the assembly and see what's going on. So this item, if I double click it, if you look here, this is just the coordinate system of the assembly. If I go into this item and double click this item here, or on the screen here, then the other items are no longer active. So the assembly is not active, these 2 items are not active. The active item is now this item. Now if I go back to the part navigator, I can see how this item was created. And now I can modify it relative to the assembly and see what's going on. And this is where you may want to double click the sketch, because it will modify it with everything else active below. So this dimension that I used originally here, this will be a little bit big. Let's go for 50, maybe 45. Let's see how it updates. Let's go back to home page, finish. So if you look there, that's more like what I wanted. So now to make the assembly active, let's go back to Assembly Navigator and double click the assembly. So I want the screw to show down a little bit. I can change that particular constraint, and it was this distance one. So let's go -5, -8. So now that's more like what I wanted. Right, so hopefully that's shown you a little bit about NX and some of the basic capabilities. In the next video, I'm going to show you how to do the drawing of this item. Thanks very much for watching.